Pre-statistics. Parameter, value, mixture, and break-even problems involving systems. Part 3. Lesson objective. Use a system of two linear equations or a linear function to solve parameter, value, mixture problems, and break-even problems. Introduction of mixture problems. Mixture problems involve mixing two different concentrations to obtain some concentration in between. Often these problems are stated as alcohol or acid solutions, but there are many more types. Chemists, cooks, pharmacists, and mechanics all mix different substances, usually liquids, which involve mixture problems. For example, you might want to know how many pure peanuts should be mixed with a 40% peanut mixture to obtain a 50% peanut mixture. You might have a two-cycle engine requiring a particular oil and gas mixture. Or you might have a recipe calling for 1% fat milk and all you have on hand is 2% fat milk and 0.5% fat milk. For example, suppose 2 ounces of lime juice is mixed with 8 ounces of water to make 10 ounces of unsweetened lemonade. So we have 2 ounces here of juice mixed with 8 ounces of water, which totals 12 ounces of a liquid. Now normally that will be one equation. The second equation will be the amount of concentration. Let's do an example. Example 5. A chemist needs 5 quarts of a 17% acid, but he has a 15% acid solution and a 25% acid solution. How many quarts of the 15% acid solution should he mix with the 25% acid solution to make 5 quarts of a 17% acid solution? So our first step is we want to define the variables. So we are asked to find the number of quarts of the 15% acid solution and the number of quarts for the 25% acid solution. So we will let x be equal to the number of quarts of 15% solution and y be the number of quarts for the 25% solution. So now we need to find our system. We want 5 quarts of the total mixture. Our first equation is going to be x plus y equals 5 because x is the number of quarts of 15% acid solution and y is the number of quarts for the 25% acid solution, and we want this to total 5 quarts. The amount of pure acid doesn't change despite the distribution of the two variables. Some of the amounts of pure acid in both the 15% acid solution and the 25% acid solution is equal to the amount of pure acid in the desired mixture. So we're going to take the 15% acid solution, the concentration, multiply that by our x plus 25% solution times y, and that will be equal to 17% acid solution is what we want, times the number of quarts, and this we know the number of quarts is 5. So now we simplify. 0.17 times 5 is 0.85. So we have our system. We have x plus y equals 5, and we have 0.15x plus 0.25y equals 0.85. Now we solve the system. I'm going to take the first equation and solve it for y. So I'm going to subtract x to both sides, and we have y equals 5 minus x. Next, we substitute this expression, 5 minus x, into the other equation, and we solve for x. So next we want to do our derivative property. So we have 0.15x plus 1.25 minus 0.25x equals 0.85. Next we combine like terms. We get a negative 0.10x plus 1.25 equals 0.85. Subtract 1.25 from both sides and divide by a negative 0.10, and we see that x is equal to 4. To find y, we substitute 4 back into one of the equations. The easiest to use is y equals 5 minus x, and we see that y is equal to 1. So putting the answer back into the terms of the problem, we have x is 4, so 4 quarts of the 15% solution and 1 quart of the 25% acid solution should be mixed together to make 5 quarts of 17% acid solution. Step 4, to check it, we compute the total amount of pure acid. So if we take 0.15 times 4, our x, plus 0.25 times y, which is equal to 1, we should get 0.85, and we do. Next we want to compute the amount of pure acid in the 5 quarts, and that's 17%, 0.17 times the number of quarts, which is 5, and that gives us 0.85. It checks. Example 6. A chemist needs 8 cups of a 15% alcohol solution but only has a 20% alcohol solution. How much 20% solution and water should be mixed to form the desired 8 cups of 15% solution? So in this case, water has 0% alcohol. So we first want to set up our variables. We're going to let x be the number of cups of the 20% and y be the number of cups of water. Next, we set up our system. We want 8 cups of the total mixture. So the first equation is going to be x plus y equals 8. There's no alcohol in water. So for the second equation, the amount of pure alcohol and the 20% is equal to the amount of pure alcohol and the desired mixture. So keep in mind that y has 0% alcohol solution. So we take the concentration amount, 20%, times the number of cups. The water has 0% alcohol, so there's not a y, and that will be equal to the 15% solution. The 15% concentration is what we want, times the number of cups that we want, which is 8. So we have our system. 0.15 times 8 is 1.2, and from our first equation we have x plus y equals 8. So solving this system will give us our answer. So for this system, I'm going to solve for x. I'm going to take the second equation and solve for x. So I'm going to divide by 0.20, and x turns out to be 6. Substituting 6 to get y, we have x plus y equals 8, which will be 6 plus y equals 8, which y is equal to 2. So to put this back in the terms of the problem, the chemist will need 6 cups of the 20% solution with 2 cups of water. To check it, we take the number of cups, so x is 6 and y is 2, and that gives us 8, which checks. And 6 cups of 20% solution would be 6 times 0.2, which gives us 1.2 cups. 8 cups of 15% solution would be the number of cups, 8 times the concentration, 0.15, 15%, we get 1.2 cups. So the amounts of pure alcohol in 20% and the 15% check. Let's do another example. Example 7. Suppose you work in the lab. You need a 15% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. Rather than pay the hefty surcharge to have the supplier make a 15% solution, you decide to mix 10% solution with 30% solution to make your own 15% solution. You will need 20 liters of 15% acid solution. How many liters of 10% solution and 30% solution should you use? Now, a lot of times in word problems, the question that it's asking will clue you in on what the variables will be. So in this case, we want to know how many liters of 10% and how many liters of 30% should we use. So we will let x stand for the number of liters of 10% solution and y stand for the number of liters of 30% solution. So our first equation will become x plus y equals 20. The number of liters of 10% solution plus the number of liters of 30% solution will equal 20 liters. The second equation is the concentration. So we take the 10% concentration times the number of liters plus the 30% times the number of liters, and that equals 15% the concentration times the number of liters. Simplifying this, we have the equation 0.10x plus 0.30y equals 3. So we have our system. Now we solve. I'm going to solve for x for the first equation. So we have x equals 20 minus y. I take that expression, 20 minus y, substitute that into my other equation for x, and we have this equation. This equation has only one variable, y. So next we do the distributive property. So we have 2 minus 0.10y plus 0.30y equals 3. Now we combine like terms, subtract 2 to both sides, and divide by 0.20. We have y is equal to 5. To find x, we substitute 5 in for y, and we solve for x, and we see that x is 15. So in the terms of the problem, we would say we need 5 liters of the 30% solution and 15 liters of the 10% solution. Thanks for watching.